Okay, so welcome to the WA2 revision for suddenly I stun. Okay, so welcome to the WA2 revision for Sec 3 A Math. Okay, just want to check, did anybody not have a copy of the materials? I just want to check everybody have. Okay, cause I don't later I need to dig out and then find for everybody. Okay, if not, I think I tell you what, I will just include. Just give me a moment. Let me just begin. All right. So this is as once again, this is the WA2 revision for Sec 3 AMF, polynomials and remainder theorem. I believe some of you guys may be Sec 4 as well, coming to revise on your old topics. Okay. So I will not drag too long about this. Okay. Just introduce myself. I think one or two of you came from my AMF boot camp if I remember correctly. But yeah, nice to see you again. So this is me, okay, in summary. Okay, I teach lower sec math, I teach additional mathematics. Okay, so what did I actually do before coming here? I actually specialize in mathematical sciences lah. Okay. In particular statistics. Okay, and what I have done in the last couple of years was to do notes, okay, up to university level. Okay, and I actually did share my notes with some of my friends. Okay, so I'm pretty sure that they got notes from me, they'll just share with other people. So free stuff. Okay, and I also taught privately for a few years. Okay. A little bit of fun fact, I climbed a mountain when I was 13. I'm pretty sure there are a few of you guys who actually did it before much younger lah. Okay, but I'm not here to compare anything like that. Okay. So that's just me as a whole. Okay, so this is just stuff that I think most of you guys have seen before, but I'll just quickly run through. So we have actually 8 outlets. Currently, I believe Woodlands will be opening soon. Okay, but the rest we have the other outlets over here. Okay, as shown over here. Okay, and this is our statistics lah, our results over here. Okay. Now the things that you expect, of course, when you sign up with us as a student, right, is you get certain resources. The main thing I think people will get right is the curated notes as well. Okay, and of course, once in a while we also do revision. We also have mock exams, and for those who are doing sciences, you also have practical notes and practical hands-on. Okay, and of course, to some extent, okay, I think just to a bit of sharing, okay, I do after class consult, okay, I do have students who text me at like wee hours, okay, but of course, I mean, if anybody is interested in signing up, I may or may not reply at that time of timing lah, okay, just let you guys know for those who are signing up, okay. Then I will leave this for a while. It's just basically the regular classes for Sec 3. For the rest of you guys over here, I actually teach one Sec 3 class and three Sec 4 A Math classes. Okay, so one Sec 3 A Math and three Sec 4 A Math. Okay, so you can find my classes over here and probably just this page lah. Okay, and you will also see my name in the Sec 4. Okay, there are some changes to classes. So it's not, I believe it's not updated lah, but you can still do an inquiry as required. Okay, then anything else we will just settle first. If you are interested to sign up. Okay, without further ado, let's just jump straight into the content. Okay, so this is on polynomials and partial fractions. Okay, which I believe most of you guys have a decent steady foundation. Okay. Main thing actually I want to focus on for this topic, right? It's not so much on how you do it, or rather the basics lah. I don't want to go too much into the basics. Okay. Rather, I want to focus more on the techniques and how you interpret the questions. Okay, and how you, because this topic itself has a lot of steps. Okay. Is for those who attended my linear law revision, right? That one not as complicated lah. It's just that the drawing of graph is not very nice lah. It's quite tall lah. Okay, but this is polynomials and partial fractions, a lot of steps involved. Okay, and so we are trying to work towards a standardized way of solving problems. Okay, so let's jump straight into this. Okay, we have polynomials and a few operations, right? And a few basic operations. Like, okay, the idea of this is that plus, minus, times, recorded, right? Okay. plus minus times divide, right? Okay. Now, you can also do this with polynomials. Okay. But when it comes to addition and subtraction, okay, when you add polynomials, right? Okay, you always add them term-wise. Okay, so basically, if it's x squared, you combine the x squared. If it's x cubed, you combine x cubed. Okay, constant, you combine constant. This is very simple stuff that I'm pretty sure you guys know how to do. Okay, when it comes to times, right? Let's say, for example, okay, you look at this table over here. I kind of summarize it over here already lah. Okay, multiplication essentially is rainbow expansion. Okay, and technically expansion only got one way of doing it lah. You just do your rainbow method and stuff like that. So when you see this side you got three terms and this side you got two terms, right? When you cross multiply, okay, there are a few things that you need to take note of. Okay, that I don't normally go through in class. First thing first, if you have three terms over here and you cross multiply with two terms over here, right? Okay, in total, you will expect to have six terms maximum. Okay, that is before you simplify any of the steps. So you will then have, after you simplify already, you will have four terms lah, in this case. Okay, but what I'm trying to say is that when you expand out the first time, you are expected to have six terms, no more, no less. Okay, that is before simplification. Okay, and once again for addition, you just add on all the term y. So x squared itself, if you look at both the brackets, there's only one x squared term. Okay, then there is two x terms and two constant terms. You just add accordingly. Okay. Now, the most important few techniques that I want to run through, right? Okay. When it comes to a polynomial equal to a polynomial for all real x, right? Okay, means to say left hand side equal to right hand side. Okay, for all real x. Okay, in this case, you will have a scenario where you need to compare. You need to compare some of the terms, no? Okay, and you will then likely compare x squared on one side and the x squared on the other side. Okay, not to worry, this one I will go through more later on. Okay, it's related to this concept called comparing coefficient. Okay, cool. Okay, then of course you need to know how to substitute values lah. Okay, so I'm pretty sure sec 1, sec 2, you all know how to substitute things like you need to know how to substitute your x values to get a y value, right? And if you need to sub in your y value, you need to reverse engineer to solve your x, right? Okay. Sec 2, you guys have done it with quadratic equations. Okay, so polynomials itself is an extension of quadratic equations lah, right? Okay, this is the more important part actually. Okay, these are the main techniques that you guys need to be familiar with. Okay, so let's first talk about okay, let's start with long division first lah. Okay, now long division itself, right, is when you have a polynomial divided by another polynomial. Okay, so a favorite example that I like to give, right, is I like to start off with 7, right? This is my dividend. Okay, if for those who know a bit of finance stuff, the word dividend means the money that you give out as like a sort of profit lah. Okay, and 2, right, is your divisor. Okay, so when you take 7 divided by 2, right, you need to ask yourself, what is the largest possible multiple of 2 that can be subtracted, that can subtract 7? Okay, in this case it's 6, right? But in order to make out 6, you need 3 of them, right? So you put 3 on top. And your job is to cancel off this term, right? You put a minus, and then you're left with 1. So then you know that, okay, I cannot divide by 2 any further, right? So this means to say that this is my remainder. And this is my quotient. So let me just write it down. This is the quotient. This is the remainder. Okay, this is the divisor. This is the dividend. Okay, and so you can actually rewrite this, right, in this particular form. 7 equals to 3 times 2 plus 1. Okay, so you see, sometimes if you cannot memorize the formula, right, use simple example like this to help you to jog your memory. Okay, and then you know 7, right, is your dividend. 3 is your quotient, so it's QX. Okay, D is your divisor, and then your RX is your remainder. So actually you can have left it in this form, right? Now this is helpful to some extent because it's important that you know this formula lah. Okay, there are some questions that can test you based on this formula. Not a lot of people actually remember this kind of formula one. Okay. Now, long division, when it comes to long division, you do the same thing, right? Okay. You need to match up the x cube with your dividend, right? So in order to make up, now, of course, we have x minus 3, right? But our focus is on cancelling the leftmost term. So obviously, you will go and match up the x cube and the x mark, right? And so you need to ask yourself, what quotient do I need to have so that I multiply this by x, right? I get x cubed. And so that I can cancel off. Obviously, the answer is x squared. Okay? So I take x squared multiplied by this thing, I will get x cubed minus 3x squared. Okay? And then, of course, I'm taking this away, ma. So when I take x cubed minus x cubed, obviously it's 0. But when I take negative 2x squared minus the negative of 3x squared, it's actually telling me that, okay, minus 2x squared plus 3x squared because it's a double negative. And then I will be left with x squared. And that's why I got this. Okay, then you just repeat this until you're left with this term. Okay, and then you will have your, oh, hold on. Okay, the remainder is 5. I think there is a typo. Okay, I'll address this later. But basically, this is the general steps to uh do your long division. Okay. Now, based on this observation over here, right, there are a few things that you need to note. Okay. Now, your divisor, right, okay, is linear. It's a degree 1 polynomial. Okay. Now, this is important because you find that when you do your long division, there is a recurring pattern. Okay. When your long division is linear, your remainder, right, will at most be 1 degree smaller than your divisor. And so you will realize that this has a very big implication on the above theorem. Okay, remainder theorem and factor theorem. It's because when you divide by a linear factor, right, your remainder is always a constant. Okay, so I will just do a quick revision on this. Remainder theorem, okay, how do you apply remainder theorem? Okay, if let's say you want to divide by this factor, right, ax plus b, right, my first step that I teach people is to always set it as 0. Okay. Okay, it's supposed to be ax plus b equal to 0, right? Okay. And then you rearrange into x equals to negative b over a. Okay, so just cancel this for me. Okay. This is what you are supposed to sub inside your fx. And that, okay, in this case, bx lah. So you sub inside here, you will get your remainder. So of course, the remainder can be anywhere between 0 or it can be negative also. Right? Now, then yes, may I have the link for the, wow. You give me a while. Do you not receive the link when you register for this? Okay, you see whether can access or not. Yeah, let me continue first. Okay. Factor theorem, right? Okay, is a very specific case of remainder theorem. Okay, in the sense that it's a factor when you can completely divide without leaving a remainder, right? So that translates to your remainder being 0. You can access, very good. So this will be equal to 0, right? Now, this one has a reverse implication, a converse implication. So it's useful and important to note that if your f, whatever thing you sub in is equal to 0, right? It implies that the ax plus b, right, okay, is a factor. Vice versa. If ax plus b is a factor, not vector, you sub inside, you will get f negative b over a. Okay, let me just write it down for full clarity. Okay, it will be equal to 0. So it has a two-way implication. You need to know how to use both methods. Okay. Okay, I there is a typo here, but I won't dwell on it. Okay. Now, You all remember the formula I taught you all earlier on, right? We're gonna use it here. Okay, so let's take a look at this question. Okay, let gx be a polynomial such that the remainder is 1 when divided by x plus 3. Okay, and the remainder is -1 when divided by x minus 2. Find the remainder of gx when divided by x minus 3 bracket x minus 2. Okay, this one I threw this question in the first time is to stun you all lah. Okay, because I think most of you guys are familiar with. Okay, I tell you that gx. Okay, you know that x minus 3 is a factor, right? Or rather, you take gx divided by this, right? Okay, so the steps, right, is you always set it equal to 0 first. Then you rearrange to get it into the solution form. Now, this is an important concept. You are supposed to swap it between the linear form and the solution form. Okay, and then take this solution form, right, and sub it into a gx to get 1. You are applying remainder theorem. Okay. Now, similarly, if you sub this inside, if you put x minus 2, right, equal to 0, right, you sub this in, right, okay, you get x equals to 2. So g2 is actually equals to -1. Now, obviously, you don't know what is gx. The question never tell you that gx, right? So you must be thinking, this question got error. make typo, then this one also got error. Okay, no, this question can solve one. Okay, the thing is, you need to know how to construct a gx. This is where a lot of people cannot solve. Okay, so I am going to go back to something that we have done before. Okay, and that is you need to be able to find a representation of gx. Now, can anyone tell me? Okay, I'm not gonna ask lah, but y'all go and take some time to think about it lah. What formula can we express gx? Something that I covered like 5 minutes ago. You take some time to think, ah. Okay, so if you realize, right, I can always write, see, any number, right, like 7, right, I can always write it in the division algorithm form. Correct or not? I can always write it as 3 times 2 plus 1. The thing is, every polynomial can be done the same way as well. So I am going to write gx is equals to the divisor times the quotient plus the remainder. Okay, we are using the division algorithm form. Okay, now this one actually you don't even need to use this. Okay, there is technically a shorter method lah, but this is the most intuitive one. Okay, the most intuitive one is to use this. Now, how is this going to help me? Right? You see, earlier on we did this part, right? And you see, you get g3 equals to 1, g2 equals to -1. It doesn't do anything, one. I cannot form any relationship between these two. So this is where this part is helpful. Now, there is a second part to this that you need to take note of first. Okay? Remember earlier on, I mentioned that when you divide by a linear factor, right, your remainder is a degree, okay, 1 degree smaller than the divisor. So if fx divided by linear, right, like ax plus b, right, your remainder is okay, this part is a degree 1, right? Your remainder will be a degree 0. That's why your remainder theorem and factor theorem always have a constant. But if divided by a quadratic instead, so for example, ax squared plus bx plus c, if you divide it by a quadratic, your remainder will be linear. 1 degree smaller at most of the divisor. So your remainder is degree 1. Now, if your remainder is degree 1, right, means you are allowed to replace Rx with Ax plus B. That is the crux of the problem. We are supposed to use this to help us. Okay? So Gx is equal to dx Qx plus this part. This is where the magic happens. Now I sub in G3. I know that this is equal to 1. But when, you see, x minus 3 is the divisor, right? But you sum in x equal to 3. What does that mean? This whole part becomes 0. Right or not? Okay? So this is the beauty of using the division algorithm form. Okay? Now G3 is equals to this part is 0, but I still have my ax plus b. So I just need to replace my x with 3. So I have 3a plus b. So theoretically, I don't need the 0 anymore. Okay? This is all I need to have. Okay, and then right, doing the same thing, right? G2 will be equals to, okay, before I go on, G3 I already declared that it's equals to 1, right? Now G2 it will be equals to 2a plus b equals to -1. Guys, what do we have now? A system of linear equation. Okay, solve for a and b, finish. That's it. Okay, so of course there are two main techniques that you need to use, right, when it comes to simultaneous equation: substitution or elimination. Okay, in this case, actually I give you another tip. Okay, when you see this kind of expressions, 3a plus b, 2a plus b, right, you notice that there's a term you can cancel off, right? If you take this minus this, then you'll be left with a, what? Right, you take 3a plus b minus 2a plus b, you cancel off the b. Then you only need to calculate 3a minus 2a, right? You're left with a single a. Then on the right hand side, you just take 1 minus -1. So you will have 2. Okay? So now that you know what's your a, of course you can find your b, right? So b is equal to, okay, choose any equation you want. And as an added note, I also tell my students, okay, if you want to choose, because both equations satisfy the same solution, right? You choose the easier one to manipulate. So naturally, I'll go with 2a plus b lah. So I rearrange that equation. I get -1 minus 2a equals to -5. Therefore, the remainder is ax plus b, right? So the remainder is actually 2x minus 5. That is my remainder. Okay? First question give you a difficult one already, right? Cool. Okay, give you guys some time to absorb this. Oh yes. Anyways, this one should be +3. Okay? So just correct that one, should be fine. Okay, let's move on. Okay. Now this part, right, is the second most common type of problem that you need to know how to solve. Okay. So I'm sure that you guys know that in Sec 2, you all learn how to solve quadratic equations, right? Okay. So in Sec 3, right, you need to know how to solve cubic. Sometimes power 4. Okay, when I say cubic, it means power 3 lah. Okay. But when I say power 4 is, okay, the name for power 4 is quartic, but you don't need to know the word quartic lah. They will just tell you degree 4. Okay. But the main consideration that you need to know, right? Okay, in Sec 2, you all learn 3 formula. Okay, I just write it down. This is a plus b, a minus b is equal to a squared minus b squared. Okay, a plus b squared, or I like to write out a plus b, right, is equal to 2a squared plus 2ab plus b squared, and then you also have the double minus variant. Okay, so you will notice that these 3 formula, right? Okay, there are something in common. This is a double plus, double minus, 1 plus 1 minus. Okay, so one way to help you to remember this kind of formula. This is for Sec 2. For Sec 3, there are also identities that you can use, right? So you have sum of cubes, a cube plus b cube. Okay, to factorize these, okay, you can always start off with a plus b first. Okay, and when you see a minus, you just put a minus b. Now, sometimes people cannot remember this, right? I will give you 2 options. Okay, option number one, right, is you compare your coefficient and to solve your uh solve for the values of the unknown law. So you assume that this is a quadratic, say ax squared plus bx plus c, right, or whatever form lah. Okay, you just compare coefficient, check the coefficient to get, okay, 1 minus 1 plus 1. Okay, then the other one, okay, you will notice the main difference between these two is that, okay, the first one is a plus, then you alternate with a minus, so it's a the sign will alternate. Okay, the sign it will be opposite, right? Then for the bottom one, it will start off with a minus and then a plus. Okay, now you will notice that this is similar to a squared minus 2ab plus b squared, right? Except that instead of 2, it's just 1. Okay, now there is a way to derive this using binomial theorem for those who are not who have taken the binomial theorem lah, but I won't go through that one here. Okay, so just need to know roughly that's how you remember. Okay, I will jump straight to this. There are two aspects of working with cubic expressions or equations. Okay, the very first thing, right? Okay, I just want to recap a bit on your quadratic. You learn how to factorize quadratic expressions, and you also learn how to solve cubic equations. Okay, so just let me change it to equations. Okay, now the very first step I will tell you to do, right? Okay, is to use calculator to get all solutions. Okay, so this one I hope that you guys have a calculator with you. If not, faster go and take. Okay, we run through this exercise while we are going through the questions later. Okay, why so? Because I want you guys, right, to adopt a shortcut method. Okay, now the very first step is you are given a cubic equation. Okay, use the calculator to sub in all the values, right, to get all your roots. Now there are a few scenarios that you need to take note of. Okay, scenario one, right, you have all rational roots. That means if all your roots are rational or at most fraction, integer, this kind that means to say cubic can factorize completely. Okay, if all your roots are rational, for example, x equals to 2, x equals to minus half, x equals to minus 1, right? This kind of solutions means you can factorize completely one. Confirm can. Okay? Now, that being said, remember that a cubic equation is a degree 3 polynomial. You are expected to have at most 3 roots. Okay? That's why your roots always in 3s one. Sometimes 2 sometimes 1 . Okay? Now, scenario number 2 or scenario number B one rational cannot be the last one not rational Okay, but then your 2 roots, right? The 2 remaining roots, right? They are irrational. Okay, if this were to happen, when you come up with your quadratic expression, right, the ax squared plus bx plus c, that factor, right, that part cannot factorize. Okay, but if you have a real solution pair, they are basically surds conjugate. Okay, your a plus square root b and a minus square root b that form. Okay, so if that's the case to solve for you need to first identify your quadratic expression first, okay, your quadratic factor first. Then you use a calculator, which you already did Use your quad formula to solve. Use your quad formula to solve. Okay? So I'm giving you guys a bit of tips already Okay, last scenario, you see a plus minus bi. A lot of y'all will see the I, right? And y'all be thinking, what the hell is I, right? Okay, I refers to complex numbers. When you see that, right, means your quadratic cannot solve. The way to prove that cannot solve or there's no solution is discriminant. B squared minus 4ac less than 0. You are supposed to prove this. Okay? So when you see a plus bi, a minus bi, you use this straight away. Okay? So it's just some tips, because I think some of you guys like to spend a lot of time checking whether your difference can factorize, can solve, this kind of thing. Guys, when you use your calculator, you already know the answer already. Okay? So these are the main 3 scenarios you need to take note of. Okay? Now, after using a calculator, right, you need to choose one of your factors Choose one of your factors. So in this case, you can either choose this, or this. And usually people will choose the easier number to work with lah. Okay, but really depends on you. Okay, choose one of them and sub it into your fx. So for example, I choose 2. F2 is equal to 0. That tells me that x equal to 2, or you write it as the linear form, right? X minus 2 equal to 0 is a linear vector. Okay, and then once you already have that, your step 2 is to write fx equals to x minus 2 bracket ax squared plus bx plus c, right? Solve for your a, b, and c by 2 methods. Number 1, long division. Number 2, compare coefficient. Okay? I will not go through all this part because I think quite redundant. Let's go straight into the example. Okay, so I hope I shared enough tips already. So the framework is this. Okay, this is the framework. You guys can refer to this later on after the after this session is over Okay, I have 1 hour to go through like 4 more questions. Okay, so given the polynomial fx equals to x cubed minus 7x plus 6, solve all real possible values of x given fx equals to 0. Basically, simple. You see this, you think of simultaneous equation. Okay, so you just equate the two together. Okay, 3x x cubed minus 7x plus 6 equal to 0, right? And the first thing you know, okay, I am going to take a calculator, right, to go and check what are all my roots. Okay, so in your calculator, and I'll put this box here, working. Okay, not in question paper. Okay, because why? I don't want to expose myself and say that okay, I already know all the answer Okay, it's just a side working for me to know. Okay, so using my calculator, right, I will have a few roots. Okay, in fact, I'm going to take a calculator and try out now. Okay, so you all go and try out. Go and use your calculator and find out all the roots. Okay, so according to my calculator, right, my roots are x equals to minus 3, x equals to 2, x equals to 1. Wow, very nice numbers. So you just choose which one you like. Okay, you choose, for example, x equals to 1. So if I choose x equals to 1, right, I need to then sub in, okay, this is fx, right? So you sub in f1 is equals to 1 cubed minus 7, 1 plus 6. Okay, 1 loop you know is 0 And what can we conclude? Because we sub this in, we get 0, right? We are applying factor theorem because the remainder is 0. Okay, by factor theorem, okay, x minus 1 is a factor. And you notice I never write x minus 1 equals 0. Okay, I didn't do that. Okay. No. So now that we know that x minus 1 is a factor, right? Okay. Obviously, you want to try to, okay, write this. Okay, and then you write this. Okay. Then you know that, okay, x minus 1 is a factor. Your remaining factor must be what? Okay, go back to what I explained earlier on about expansion. Now, when you have a factor times another polynomial, right? How do you get a degree 3 polynomial? Okay, if your first factor is a linear, confirm your second term has to be a quadratic one, right? This was shared earlier on. The product of two factors, right? Two polynomials, okay? The resulting polynomial has a degree of this degree times this degree, which is 1 plus 2, right? So this part, you have ax squared plus bx plus c, okay? Now, our job is to actually find your a, b, and c, right? So there are 2 ways to do it. Some people, right, will tell me, okay, I want to expand everything out. Some people will tell me, okay, I do long division. I leave it to you. Okay, so I will not do long division because later on I will need to present long division. So I might as well do compare coefficient, right? So now I think most of you guys, if you explain fully, I'm sure you know how to do it now. Okay, but I like to do one thing. You see, this is degree 3, right? This is x cube, right? And you see, when you have this kind of form, there is only one scenario, or rather one product that will give you x cube, which is your x times ax squared. And by observation, you will know that a is actually equals to 1. Because some people will say, okay, ax cube equals to x cube, right? Therefore, a equals to 1. Some people want to write this, by all means. But if you can see this, straight away write this in already. Don't waste time. Okay? And by doing the same thing, you can get c is equals to minus 6. Okay? A few things to note. I think for presentation, right, some of your schools may tell you to write, okay, comparing x cube, comparing constant. Okay, then the next one, you have x and you have x squared. Leave it to you, whichever you prefer. Okay, sometimes I see mood one lah. Okay, so in this case, I feel that okay, x squared term is absent, so I try my luck with x squared. Okay, so compare x squared. Now, for this one, you need to be a bit more observant. Okay, now you have x times x terms, you get x squared, right? You also have x squared times constant, you get x squared, right? So these are the two scenarios, right, when you will get an x squared term. So just be a bit more careful when you do this. Okay, you can do your multiply like that, and then multiply like that. So then you will have b minus a equals to 0. Therefore, a is equal to b, and you already know that a is equal to 1. Therefore, b is equal to 1. And so, based on this observation, your fx is actually equal to x minus 1, x squared plus x minus 6. Okay, this part, as we already know from earlier result, right? Okay, you go back to this. Our remaining two roots, very nice, right? Which means can factorize. And so actually you can use this to help you to factorize lah. Okay, how? You get x minus 1, x minus 2, x minus 3. Oh, sorry, it's supposed to be x plus 2. Yeah, no. X plus 3. Yes, this is correct. So this is my fx. Then when I set this equal to 0, right? Here's the situation. You see, I have a factor here, I got a factor here, I got a factor here equals 0, right? So this is where we apply the zero product principle. Okay, but layman terms is basically when you're something like something, right? As long as one of these numbers is a 0, you multiply by anything by 0, right? It will still be 0. Okay, so you will then conclude that each of these can be 0, right? So you set x minus 1 equal to 0, or x minus 2 equal to 0, or x plus 3 equal to 0, and then each of these components are linear components. Just solve them reverse. Okay, x equals to 1, x equals to 2, x equals to minus 3. Okay, so these are your three solutions. Cool? So I hope you guys have practiced your calculation keying in the calculator. Okay, now part 2, or rather part B, right, is a bit unique, or rather not so commonly tested. Okay, we have a polynomial and we have the intersection of a line. Now when y'all see this, you need to think back. What is the impact of a curve intersecting a line? It's basically when you see the word intersect means simultaneous equation. Okay, it's just that you guys never learn how to do simultaneous with a cubic and a line, right? So because you guys have done quadratic, maybe not cubic. Okay, so in this case, I am doing a cubic and a line. Yes, you can still solve it, but you need to get rid of one of the variables. Okay, obviously it won't be y lah, as in you won't be x Okay, you will try to solve it in terms of y. Okay, so you need to first rewrite y is equal to minus 3 minus x. Okay, you need to be able to rewrite that one first. Okay, then you have y equals to x cubed minus 7x plus 6, right? So, of course, at this point of time, you do your simultaneous equation. Okay, so then you will have x cubed minus 7x plus 6 equals to minus 3 minus x. Okay, then you do a bit of rearrangement. Okay, there we go. Okay, so this is another cubic equation. I will bypass most of the steps. Okay, so once again, sub in your coefficients. Okay, now my roots, right? I only got one. Okay, so I put roots working. Apparently, my only solution is minus 3. Cool, So that means to say my other solution is the plus minus I thingy, right? That's where you know later on when you factorize, no solution. Okay, so we know what is the direction we are heading towards. Okay, so of course the first thing you do is to do what? Of factor theorem, right? So you sub in x equals to minus 3. Okay, you get minus 3 cubed minus 6 times minus 3 plus 9. Okay, you get minus 27 plus 18 plus 9 equal to 0. Okay, so this part, by factor theorem, x plus 3 is a factor. Okay, I think at this point of time, you guys understand where this is going, right? So now I have, let's see, x cubed minus 6x plus 9 is equal to x plus 3 times a quadratic. Okay, now you want to use complex coefficient by all means. Okay, I will now show you all the long division method. So long division, right? Put the divisor here, the dividend, and put the divisor here. Okay. Obviously, you expect your remainder to be 1 degree smaller than the divisor, right? Which is constant. Okay. So to match x cubed and x, you need to multiply by x squared. And so x squared times x is x cubed. X squared times 3 is plus 3x squared. And notice over here, right, that this equation doesn't have a 0x squared. It doesn't have an x squared term. So I like to do one thing. I like to put a dummy variable here. Okay, so I put a dummy plus 0x squared. Okay, this way, when I do my long division, I don't get confused. Okay, but of course, I am subtracting by this, right? So I will now have negative 3x squared minus 6x plus 9. Okay, and in order for me to multiply something to x to get negative 3x squared, I need negative 3x. Okay, so negative 3x I times x, negative 3x squared. Okay, then negative 3x times 3, I will get negative 9x. Okay, once again subtract. Okay, you will have this part gone. Then I will have minus 6 minus 9. So minus 6 plus 9 3x plus 9. Okay, then the last one very obvious is 3. Okay, so 3x plus 9 cancel off. Remainder must be 0. Don't be surprised. Okay, because you already say that x plus 3 is a factor. You don't expect your remainder to be non-zero. Correct or not? Okay, so this is your quotient. So I will now have x squared. Sorry, I will now have this expression x cubed minus 6x plus 9 equals to x plus 3 times x squared minus 3x plus 3. Okay, earlier on we already know, right? This part, no solution, right? We need to prove it. And the way to prove it is to use the discriminant. So identify your B, your A, and your C. B squared minus 4AC is actually equal to negative 3 squared minus 4 times A times C, which is 4 times 1 times 3, right? This is equal to negative 3, which is less than 0. Now, discriminant tells you that there is no real roots. So that explains why when you set, you can conclude that, okay, x squared minus 3x plus 3, right, has no real roots. Therefore, x cubed minus 6x plus 9 equal to 0 only has one solution. x equals to minus 3. The other two are non-real solutions. Okay, so these are the techniques that you need to know lah. Oh, okay. I think we take a break first. Okay, we come back in like 5 minutes time. Okay, so maybe around 8:23. So, okay, anyone got questions can ask. Okay, yeah, leave this here if anybody need to see. Okay, toilet break, toilet break. Wow, everybody like quite zai. Okay, I take it as almost everyone's back. Okay, cool. Let's move on. Oh, extra working space, don't need. Can manage to squeeze everything in one page. Okay. Question three. Now this one, right? Okay, I give you in this particular form: x cubed minus one plus x bracket x minus one. Now a lot of people will tend to expand this directly, and then you try to factorize. Okay, but you might have no you might want to notice that there is a reason why it's being put this way. Now you see, this is put very nicely for you: x cubed minus one, right? Give you 5 seconds to think. Does this strike a bell to you? I hope it does. Because this is difference in cube. And so difference in cube, you can use the formula, right? X cube minus 1 is actually equals to, okay, these are your terms, right? You will have x minus 1 bracket x squared plus x plus 1. Okay, this part over here is actually your x times 1 lah, but x times 1 is just x ma. Okay, so I just leave it as x. Okay, now why do I want to do this? Because if x cubed minus 1 is this, right, then x cubed minus 1 plus x bracket x minus 1, right, is actually equals to x minus 1 times x squared plus x plus 1 plus x bracket x minus 1. And for those who have keen eyes, there you go. Okay, x plus x minus 1, x minus 1, you can factorize out, right? Okay, so you will have x minus 1 bracket x squared plus x plus 1 plus x. Okay, like your grouping, right? And so you will have x minus 1, x squared plus 2x plus 1. Okay, now this part, once again, it strikes a bell, right? This is actually your double plus the special identity, right? A plus B whole thing squared. Okay, the thing is how I check. This is a square number, this is a square number. Then just check before you square it. Does the product times 2 give you 2x? If yes, you can apply this formula. So you will have x minus 1 bracket x plus 1 whole thing squared. Okay, so this is how I factorize it completely. Okay, so this is for part A. Now part B, hold on. Okay, part B, I missed out equal to 0. Okay, so just take note of that. Because when you solve, you cannot be equal to nothing, right? It has to be an equation. So this is actually what I'm asking you guys to solve, right? And so you need to take note of the word hence. Okay, the scale of the hence over here, you need to relate back to your previous part. Okay, and so how is this related to your previous part? You see, I compare this side by side. A, A x power 6 x cubed minus 1 minus 1 2x squared x 2x squared minus 1. You all already noticed the pattern, right? See, this is x and x is written as 2x squared. So actually, if I did a substitution like u is equal to 2x squared, right? Then I look back at x cubed. Do I get 8x power 6 or not? Yes, indeed I do. Okay, because this can be written as 2x whole thing squared whole thing cubed. Sorry, not whole thing squared lah. Okay, 2x squared whole thing cubed. Okay, so indeed I am able to convert it into a form that I recognize. Okay, so if you let u is equals to 2x squared, you will then have, okay, fx. Okay, I think for notation wise, let's change it to gx. Okay, so gx, right, okay, is equals to 2x squared whole thing cube minus 1 plus 2x squared times 2x squared minus 1, right, is equal to 0. But then you know that this whole part, I can always replace it with u, right? So I will now have gu equals to u cubed minus 1 plus u minus 1. But the thing is, I already know how to factorize this from my part A answer. So this is actually equals to u minus 1, u plus 1 whole thing squared. But if I set this equal to 0, right, I will therefore have u is equal to 1 or u equals to minus 1, right? And if you work backwards, you go back to your before substitution. Okay, you will have 2x squared equals to 1 or 2x squared equals to negative 1. Now guys, x squared is always non-negative. So you all notice something already, right? Okay, this part over here cannot have any solutions because you cannot square root a negative number. Okay, whereas for this one, can. So you will then have to reject because x, how do you call that? Okay, because 2x squared cannot be negative. Okay, I write a bit nicer. Okay, so you reject because 2x squared cannot be negative. Okay, but this part I can solve. So just need to rewrite as x squared equals to half, x is equals to plus minus 1 over root 2. But for those who have learned certs, I believe most of you guys have learned certs, you need to rationalize this. So it will be, okay, this type, once again, a quick revision. When you want to rationalize this kind of form, right, okay, you put square root 2, square root 2. Okay, so you have root 2 over 2. I think normally for this kind of questions, you can leave it in 3SF lah, but I usually tend to put exact value if it's not too complicated. Okay, but this one depends on your school and also depends on the O level requirements also. But most of the time, I habitually I will leave it in this kind of form if it's not too complicated to simplify lah. Okay, but if you want to leave it as a search, please rationalize it lah. Okay, so you see just by doing a few factorization, right, I bypass a lot of steps. Okay, and that is the magic of this question. Okay, at this point of time, I think everybody okay, can move on. Okay, just 1 or 2 minutes to internalize this question. And I think you realize that this question I present very fast because the steps required is not as strong as the last 2 questions. Okay, by the way, close bracket. Okay, let's move on. Now, I am left with a few questions over here. Okay, partial fractions. Okay, just a few pages lah. Okay. Now I will take some time to go through this part. Okay. In more clarity. Okay, because I think these questions are not too difficult, but you need to be a bit more sensitive to the different types of the partial fractions required. Okay. So I think a lot of students, when I first taught them partial fractions, right, I think they were not able to come up with the different types. So I will just quickly run through. I spend the next few minutes or so to run through the different format. Okay, you have 4 different types. Okay, and the thing is, in Sec 2, you all learn how to combine fractions, right? Okay, in Sec 3, you need to learn to split them apart. Okay, and so I will go by with a very basic with a few of the cases over here lah. Okay, now fx over ax plus b cx plus d, right? This is a pretty standard one, right? And how I like people to remember, right, is, okay, let's say you have 1 over x plus 1 plus 1 over x minus 2, right? Okay, you will then want to combine the fractions. Okay, so you combine fractions, you will have x minus 2 plus x plus 1 over x plus 1 x minus 2, right? And so you realize that you simplify this part, it will just be your regular fx. So you realize that actually to split this kind of fraction out, right, not very complicated. Okay, it's really just this thing and this thing bare bone split. This one, I believe most of you guys got no issues. Okay, but for the remaining three cases, okay, you need to be a bit more careful with the approach because these two cases are quite unique. Okay, for a start, I want to modify this one a little bit because this is not the most general form that you will see. Okay, the most general form you will see, right, is actually the following. Okay, fx over ax plus b squared times a second linear factor. Most of the times, right, it will be this form. It will usually never be this form because too simple already. Okay, so then you need to split into three different partial fractions. This is a general guide. Okay, so you will actually have a over ax plus b, okay, plus b over ax plus b squared plus c over cx plus d. Okay, by the way, any changes that you see over here, right? Okay, I have a solution scheme ready actually. The solution scheme will have the updated changes. So when you guys refer to the solutions, not to worry lah. Okay, I have the solutions. When I upload it, then you guys can see it lah. Okay, so these are the different. These are the scenario. Okay, you will first have this term. Okay, and then you will have a square, right? The repeated part, right? Okay. Then you will have the linear term by itself. So actually this one is just splitting up this one and this one. Except for this ax plus b squared, right? You need to do additional work. Okay? The principle behind this, right? Why you need to do 2 times, right? Has got to do with a bit of linear algebra, but it's not something that we teach in O levels. So I don't want to go into that kind of depth. But basically, it has got to do with the concept of multiplicity. Okay? And that's why you will see power of 2. And you see these 2 repeat. Okay? So I think just need to be a bit more cautious. Just split as per normal, but make sure you have your 1 and your 2. These 2 is together one, always together. They are like couples. Okay? Last but not least, or rather second last, right? You have fx over this part and this part. Now, of course, actually, this part in general, right, doesn't have to be this type of form. But most of the time, you'll see as a x squared plus a kind of form, right? Okay. In general, actually, as long as this factor cannot be factorized, right, it will always be like that. So it can even be a x squared. It can even be this form, but cannot factorize. Okay, when you encounter this scenario, right? Okay, actually you very seldom will encounter lah. Usually it's like that one. You will give you a very clear cut cannot factorize one. Okay, so you will actually need to do this component over here, which you will realize is very different. Okay, on the numerator, you will see ax plus b. This is linear. Whereas everything else, right, you see a, b, right? A, B, C. Okay, why is it not so special? Okay, it's because your denominator is a quadratic. So your numerator can be at most a linear. Then some of you might ask, how come this one, right, is not linear as well? Okay, the reason is because the denominator can be factorized. Okay, so if you think about it, you combine these two together, right? Okay, yeah. How may I? Okay, may I know how to split up the ax squared plus bx plus c? It depends. Okay, so when you encounter this situation, right, you need to check whether you can factorize or not. You must check if you can factorize or not first. If you cannot factorize, right, it will actually fall under the non-factorizable component. That's it. If you can factorize, right, and if you get something like ax plus b, cx plus c, right, you do your partial fraction based on that. Okay, I got a few examples I'll show you later on. But you get the rough idea, right? I hope you do. I will show you later, don't worry. Okay, good. So, anyway, back to what I was saying, right? Okay, the reason why this one is B and A is because if you combine them together, you will get back a quadratic. Like, if you combine these two together, you will actually have something like this. Okay, but I don't want to go too much into this. Okay, just follow what you have, good enough. Okay, then of course pull out the C over dx plus d. Okay. Now the last scenario over here is when you see fx over gx. Okay. Now when fx is the same degree as gx or above, it means that it is improper. If this happens, you need to apply long division. Confirm must do ah. A lot of people that I taught they never do. Then after that tell me, how come my answer don't look very correct ah? It's because you all never go and do your long division. That's why it's wrong. Okay. So let's take a look at some of the examples here. Okay. You have 4x over x squared minus 1, right? Okay. Now, you need to ask yourself, my denominator don't look like any of the forms that I have. How ah? Okay. So this one, you need to check denominator can factorize or not. Okay, you need to factorize first. So 4x over x plus 1, x minus 1. Then you split into your a over x plus 1 plus b over x minus 1. Okay? This is how you all actually come out with the formula. Okay, for this one, 4x over x cubed minus 2x, right? The denominator, ask yourself, can factorize or not? Can. And you can take out x, right? So you have 4x over x bracket x squared minus 2. Okay? Now, something that you might have realized, you can cancel out the x term. When you all see this, you can do it. Because you're going to end up cancelling it anyways. Okay, so you can go ahead and cancel. So this will become 4 over x squared minus 2. But by then, nothing to partial fraction anymore. Okay, so it's just like that only. Okay, because this part cannot factorize. But okay you won't encounter this for your A math lah. So quite unlikely this is the example that you will be tested on lah. Okay, but otherwise it will, because this part technically is not factorizable, but it's not in the form that it's not in the correct form. So you cannot apply the techniques to this question. So this one is actually not a very good example. But I just thought I highlight this to you guys lah. Okay. So let's just write down not good example. Okay. Then this one. Okay. Somehow I'm obsessed with the x. Can I just remove the x? Actually, never mind don't need lah. So this one you need to ask yourself. Okay. Denominator I can factorize out what? X. So 4x over x bracket x squared plus 4. This one is a good example. Okay, I can cancel out the x, but I will have 4 over x squared plus 4. Okay, example quite lame lah. So to add up a notch, maybe you want to put, the question can test you x minus 1. Okay, so when you have this form, right, okay, you can apply your partial fractions. In particular, you can write it as ax plus b over x squared plus 4, okay, plus c over x minus 1. So those who ask me questions about what are the scenarios you will encounter, right, this one is not a good example. And you can take it as I purposely put it there lah, because this one is not a good example. You won't actually encounter this kind of scenario one. Because remember, the formula is ax plus b, not ax squared plus b, right? It's not ax squared minus b. Okay, that one important. And then this part, yes, can encounter, but usually with another factor lah. Okay. The rest, you kind of get the idea. But for this one, okay, maybe I put a plus 1 over here. Then I make it a good example. You need to ask yourself, is this fraction proper or improper? Okay, you can tell, right, by comparing the top and the bottom. On top is degree 4, right? And below is degree 3, right? So you know, you need to apply long division. Okay, once you do your long division already, then you do your partial fractions. Okay, so of course this part you can break it up into x bracket x squared plus 4. So you will then be able to break up into a quotient plus a over x plus bx plus c over x squared plus 4. When you send the annotated slides, I didn't get to finish copying. Oh, okay. I believe I will upload the solutions online, so not to worry. Anyways, later I can go back to the question. Okay, so you let me know which question you haven't copied down finish yet. I let you know. I let you copy. Okay. This one, once again, you need to do long division, right? Then you need to factorize this one, right? Become x bracket x squared minus 1. And this part can factorize further to become x minus 1, x plus 1. Then you have a quadratic factor, which you cannot factorize, of course. Okay, and it's in the form that is being tested lah. Okay, this kind of question is very unlikely to come out. Okay, so because it's too many things already lah, you usually won't encounter this kind of issues. But if you do, just do as per normal and with your 平常心. Okay, don't need to think so much about it. Okay, but very rare will come out lah. Where will I upload it at? I think you have instructions to upload lah. But later because the previous WA I did upload also. So I believe I'll get to upload, then it will be shared across. Okay? Yeah, not to worry about this lah. If not, feel free to reach out to us. Then anyways, I will upload one lah. I will upload within a few days one. So not to worry. Should be the same. It's either the same file or I think it will give you updates. Okay, decompose the following as a sum of partial fractions. Okay. I have two examples over here. Okay, I have 2 bracket 4x squared plus 1 divided by 4x squared minus 1. Okay, the first thing you need to ask yourself is how? How? Okay, you always need to check your denominator can factorize into what first. Okay, so this one you can factor into what? I'm sure you guys know it's a difference of squares, right? So it's actually a 2x plus 1, 2x minus 1. Okay, and then on top will be 2 bracket 4x squared plus 1. Okay, a good idea is actually right to expand first. Hey, but hold your horses. I just realized this question, right, is it proper or improper? Okay, it's improper. So actually, before you even do any of this step, right, please make sure you check whether it's proper or improper. So a lot of people, including myself sometimes, if you like to rush through the steps, you will miss out on the specific detail of, okay, I need to do my long division. Okay, so yes, let's do long division first. Okay, ax squared plus 2 divided by 4x squared minus 1. Oh, cool. Like very fast, Okay, but what is my quotient? In order to match 4x squared and ax squared, I need to have 2 times of it. And so I multiply 2, I will have like that, and then like that. So actually, this will have been written as 2 plus 4 over 2x plus 1, 2x minus 1. Okay? And so, right, how you need to ask yourself, right, what is the partial fraction that is required? So 2 is already out, right? You need to focus on this part. Okay, and then ask yourself, can you speed up directly? Do you need to look for special terms? Okay, if don't need, then it's just a over 2x plus 1 plus b over 2x minus 1. Okay, so for this one, right, this 2 is not in play, so we can ignore it. Focus on this component. Okay, so I will focus on 4 over 2x plus 1, 2x minus 1 equals to a over 2x plus 1 plus b over 2x minus 1. So the thing is, in order for you to compare, right, you need to make sure that your left hand side and your right hand side is comparable. And how do you do that? You combine the fractions. Okay, left hand side by default is really like that. But on the right hand side, you see the denominator on the left hand side is like that. And this is the consequence of combining the fractions on the right hand side. So let's do that. Okay, so this part I will have 2x minus 1 times a plus b bracket 2x plus 1 over this whole chunk of stuff. And right off the bat, you know that denominator same, right? You have 4, you compare the numerator, you have 4 equals to this whole chunk over here. So actually, right, we can just jump straight into this. 4 is equals to a bracket 2x minus 1 plus b bracket 2x plus 1. Okay, and then the thing is you need to sub in different values of x, right? Or you can expand and compare coefficient. Now, some of you may want to expand, some of you may want to compare. I leave it to you lah. Okay. But for this question, maybe I expand. I see whether it's helpful. So I have 2ax plus 2bx minus a plus b. And you know that comparing this and this, right? Okay, you will actually know that this part is 0, this part is 4. So I have minus a plus b equals to 4, or 2a plus 2b equal to 0, or simply a is equal to negative b. So you actually have a simultaneous equation. Now I am doing the expand and compare part, right? Okay, you can also alternatively sub in values for x. Okay, see which is your preference. Okay, and you can quickly notice that you will have a is equal to minus 2, b is equal to 2. Therefore, 2 bracket x 4x squared plus 1 over this whole thing, right, is actually equals to 2 minus 2 over 2x plus 1 plus 2 over 2x minus 1. Okay, so that will be your solution for part A. Okay. Okay, let me move this a little bit. Okay, so this is part A. And now I do part B over here. Okay. Okay, part B is a slightly more tricky, but let's take a look. Okay. I have 2x squared plus 12x minus 8 over 4, x power 4 plus 4x squared, right? Now, is this proper or improper? Proper, okay? So, no need to do long division. But you need to take a look at the denominator first. Okay? 4x power 4, x power 4 plus 4x squared, right? Okay, I can factorize to give me x squared bracket x squared plus 4. This part must be very careful, because why? Notice that I don't have the, you see, I have a x squared term. This is repeated. And in addition, I also have a quadratic that cannot be factorized in the form of x squared plus 1. Okay, so actually, then you can write it as, oh, oops. Okay, you can write it as 2x squared plus 12x minus 8 over, like that, right? And so you know that you can split it up into a over x plus b over x squared. This part accounts for your repeated roots, your repeated linear factors. Okay, and then you add in your cx plus d over x squared plus 4. Okay, once again you combine everything together, you will then have 2x squared plus 12x plus minus 8, okay, equals to, let's take a look. In order for me to get this form, or rather, I think easier for you guys is I factorize out for you guys first. Okay, then you need to ask yourself, a over x, what am I missing in the denominator? I am missing 1x and the quadratic factor, right? So I need to take a multiplied by x multiplied by x squared plus 4 plus b x squared, right? Am I short of x squared or not? No, I have already. So I'm short of the other expression, which is x squared plus 4. So I need to multiply b by x squared plus 4. And lastly, cx plus d, right? I am short of the x squared term. So I just submit x squared. So this is the form that I'm required to solve. Okay, I think not very nice, right? I see whether I can squeeze it a little bit. Yeah, try my best. Okay. This method maybe not so wise to compare coefficient or to expand fully. So I just do substitution. Why substitution? Because you see, I got some x terms over here, which I sub in, very fast I can remove some of the terms. So let's try sub in x equal to 0. Okay, I will have then I will therefore have negative 8 equals to 4b. And so my b is actually equals to negative 2. Correct or not? And now I can sub in different values of x, y, different values of x. Then I realize that, okay, maybe not so easy, right? We try first. Okay, so x is equals to negative 1. You will have 2 minus 12 minus 8, which then you will get minus 18. Wait, let me see. Minus 12 minus 8 minus 20. Minus 20 plus 2 minus 18. Okay, can. Okay, so then on the right hand side, I will have negative a. Wow, like very tedious, right? Okay, so sometimes I think the point of me showing you guys this is sometimes you brute force doesn't work one. Okay. Uh Sometimes one method is better than the other method. So if you were to sub in values, right, it might be a bit messy. Okay. I know some of you guys can do it. So let's do a switch rule. Okay, let's do the other method. Let's just explain everything. Very fickle-minded, right? Okay, so I just explain everything. Ax cubed plus 4ax plus bx squared plus 4b plus cx cubed plus dx squared. Okay, and then you rearrange a plus c x cubed, okay, plus b plus d x squared plus 4a x plus 4b. Okay lah, doesn't look that bad lah. Okay, and so now I have okay, I can compare coefficient, right? I know that a plus c is equal to 0. So quite obviously a is equal to negative c lah, right? And then I also have b plus d is equals to, let's see, okay, this is the x squared term. I compare with x squared is equals to 2. Okay, then I also have 4a is equals to 12. This one very nice. I can solve for a directly, right? So a is equal to 3. Okay, and then I also have 4b is equals to negative 8. So b is actually equals to negative 2. Okay, and then using these, you can solve for your other values very quickly. Okay, d is equals to 4, c is equals to negative 3. So actually, once you know all these values, right, you sub back in your original equation, you will have 2x squared plus 12x minus 8 over x squared, or rather, you just copy down the original equation. Okay, x4 plus 4x squared. This will be equals to 3 over x minus 2 over x squared plus 4 minus 3x over x squared plus 4. That is your final solution. Okay? Okay. I give you all 1 minute to copy down. Okay. Okay, the last question actually very fast one. I will speed run that one. Okay, I take it as your copy finish already. Okay, if you need me to go back, I maybe will spend 5 minutes to go back and then you'll copy down. Okay, last question. Find the sum of partial fractions of the expression x power 4 plus 16x squared minus 80 over x power 4 minus 16. Now, right off the bat, x power 4, x power 4, long division. Okay, so let's do it. Okay, now, this part actually, sorry, copy wrongly. Okay, this part actually very fast. You know why not? Because x power 4, x 16, x power 4 and constant. You actually only need to modify the first term and the last term. Okay? So Okay, you only need one of these things, right? So you will have x power 4 minus 16, whole thing subtract, you will be left with 16x squared minus 64. And so your partial fraction, right, will actually be 1 plus 16x squared minus 64 over x squared. Sorry, over x power 4 minus 16. Okay? And then the next thing you need to do is to factorize as per normal. You realize that, okay, x power 4 minus 16, I know I must factorize it into the following form, right? So you think x power 4 minus 16 is actually x squared whole thing squared minus 4 squared, right? So then you can apply your technique, okay, the difference of square, right, as follows. Okay, of course you can also factorize out the numerator, right? So you will have 1 plus 16 bracket x squared minus 16. Okay, is it 16? No, it's actually 4. Okay, over x squared minus 4, x squared plus 4. Oh, cool, interesting. What do you notice? I can cancel out something. And so I'll be left with 1 plus 16 over x squared plus 4. Hey, I didn't even need to do any partial fraction. Okay, so what actually happened if you didn't actually use the cancellation method? You will have done your partial fraction. You will put a over x minus 2 plus b over x plus 2 plus cx plus d over x squared plus 4. And then you will find that your a and your b is actually equal to 0. It will happen to be like that. Okay, so sometimes, right, very rare, but you can cancel out common terms, go ahead and do it. Okay? But very rare this kind of things will happen. Usually they won't give you very nice one. So now that you know this, right, question asks you to prove that this entire thing is more than 0. But here's the thing. This part is positive. In order for the whole thing to be more than 0, I need to show that this component is more than 0. And how do we do it? Very simple. Numerator is positive, right? Denominator, see, x squared is more than 0. So x squared plus, okay, x squared is at least 0 lah. So x squared plus 4 is confirmed more than at least 4, but it's already positive. So no matter what value of x, right, 1 plus 16 over x squared plus 4, right, is always positive. So I already proved already. Okay? All clear? Okay, the purpose of this question is actually not so much on testing you partial fraction. It's actually an extension question lah. It's more like you may be asked to show this kind of facts. Okay, but very rare. It's just that I thought that this will be useful for you guys lah. Okay, so I think just nice. Okay, it's 9 o'clock already. So I will open up 5 minutes or so. If anybody got any requests or what, you can ask. They need to copy down any particular question, right? The person will PM me, right? Let me know. The rest you can go already. Thank you very much for coming. I hope that today's session is fruitful for you guys. Okay? Thanks, guys. Question 1, okay. What do I mean by division algorithm in question 1? Okay, so basically, this question, right? Okay, why did I use the division algorithm? Okay, because gx itself, I never tell you what's the function, right? Correct or not? So if you just copy this down, it's not going to be very helpful. Okay, so your thinking process actually must be as such. I need to find an expression gx that will help me to be able to uh, make sense of the question, right? Because the end goal is I want to find the remainder when I divide the function, right? The polynomial by x minus 3, x minus 2. Okay, but I cannot do that if, let's say, for example, right? I can't do that if I don't have an expression, right? So I need to come up with an expression. Now, how division algorithm actually helps, right? Is that I'm able to express this function as something times something, right? Plus a remainder. But you see, this divisor, right? Okay, this dx, right? Because I have the scenario where I can divide x minus 3 and x minus 2, right? Correct or not? So, okay, let me write out in full. Okay, gx is equal to, in one instance, x minus 2. The quotient can be anything. It doesn't have to be necessarily the same thing throughout. But then I have ax plus b, right? Now, when g is equals to 2, for example, you will then realize, right, that I sub in this value as 2, correct or not? And so I have 2 minus 2 times qx plus 2a plus b, right? Okay, but then 2 minus 2 is 0, right? Correct or not? So you multiply by any quotient, it's still going to be 0. And that's why this division algorithm helps me to understand, right, that when I sub in a particular value, the whole part with the quotient, right, and the divisor, right, gone. I actually only need to focus on the ax plus b. Okay, but I I just want to ask, right, you understand why I got ax plus b or not? That one is the more important one. Okay, so ax plus b, right, is like I mentioned, when you do your long division, let's say, for example, this is anything. Okay, when you divide by a linear factor, your remainder, right, is always a constant. You understand why remainder theorem and factor theorem, right? The remainder is always constant. It's because of this. Okay, this linear is a degree 1, right? And so your constant is actually a degree 0. The difference in degree is 1. Okay, but when you change this whole thing, okay, let me add in a new page. When you change the whole thing to a quadratic, okay, so you have some sort of polynomial here, let's say fx, right? Okay, the thing is, when you compare the leading term of fx and this one, right, you will naturally cancel away the ax squared, right? You will then be left with this part, which you cannot eliminate by any quotient, right? You multiply by any quotient, you cannot eliminate. Okay, the smallest degree of a quotient, right, is a constant, right? So if your degree is just a constant c, right, or constant, right, you multiply this constant with bx plus c, right, and you take it away, right, your final answer is at most going to be a remainder of a linear term. So how does this work? This divisor, right, is degree 2, right? This remainder is always 1 at most, right? 1 less than the divisor. Does that make sense? So if my divisor is a quadratic, my remainder is at most a linear. That's how I got ax plus b. Okay, this actually is not very commonly tested or taught in this topic lah. But if it does come out, it's a killer question. Okay, did I make it clear for you? Okay, my advice to you for this question, right, is you try to do more long division problems. If you do those quadratic, you divide by quadratic, you divide by cubic, right, you will see what I mean. The remainder will always be at most 1 degree smaller than the divisor. It's like that one. Okay, because you need to ask yourself, your quotient times divisor, how much can you cancel away the terms? It will always be at most 1 degree smaller one. And that's why your remainder is like that. Okay? Okay, any more questions? Anyone need to copy any particular questions? I got one person say need to copy this one, right? Oh, it's already. It's already. Okay, cool. Okay, if not, then that's it already. I'll be closing this already. Thanks, guys.